Okay, so previously we used boxes and Venn diagrams to compute probabilities. In order to use boxes and Venn diagrams, you need to know the probability of both. We were given the probability of both children getting the flu, and we were able to do a box or a Venn diagram to get other probabilities. If we're given, if we're not given a probability of both, but if we're given conditional probabilities, we can make a tree. So this example here will be better served by making a tree. Here that we're not given explicitly given the conditional probabilities, but the conditional probabilities are fairly evident. Anyway, this example, 7 out of 10 children in a Lego club have brown eyes. 2 children are randomly chosen. Want to find the probability A, both have brown eyes, B, at least one has brown eyes, C, exactly one, D, at most one has brown eyes, E, neither has brown eyes. So these are probabilities among the sample of 2 out of the population of 10. So we want to use a tree. So the conditional probabilities, we're not explicitly given them, but we can compute them because if we're randomly choosing 2 children. So if the first child has brown eyes, then there's going to be 9 children left. Initially, there's a 7 out of 10 chance that a child will have brown eyes. But if the first child picked has brown eyes, there's going to be 9 children left, and 6 of the remaining 9 children will have brown eyes. So the conditional probability that the second has brown eyes, if the first has brown, would be 6 out of 9. And the conditional probability of the second having brown, if second not having brown, if the first is brown, would be 3 out of 9. Okay, so let's make a tree here. Okay, so the first child either has brown eyes or not, and they have a 7 out of 10 chance of having brown, 3 out of 10 chance not having brown. After the first child has been picked, there are 9 children left. Now, if the first child had brown eyes, there'll be 6 of the remaining children will have brown, 6 out of 9, and 3 out of 9 will not have brown. If the first child did not have brown eyes, then all 7 of the remaining 9 children will have brown eyes, and 2 will not. So this second layer here, these are conditional probabilities. And if you know the conditional probability, you can get the probability of both by multiplying. So this is the formula, one of the formulas for conditional probabilities. The probability of both C2 and C1, probability of C1 times the probability of C2 if C1. So we can get the probability of both by multiplying. So we want to multiply along this path here. 7, multiply fraction, and multiply the numerators, multiply the denominators. 7 times 6 is 42. 10 times 9 is 90. So it's 42 out of 90. That would be brown. And then this path here, 7 times 3 is 21. 10 times 9 is 90. That would be brown, and then not brown. And then this path here, 3 times 7, 21 over 90. Not brown and then brown. And the last path, 2 times 3 is 6. 6 out of 90. Neither one has brown eyes. These should add up to 1. 90 out of 90, which is equal to 1. So that's our tree. And then we can use that to compute other probabilities. This is our sample space here. If they ask about the sample space, there's 4 possible outcomes. They both could have brown eyes, one brown, one not brown, one brown, or neither have brown eyes. Okay, so the probability they both have brown, well, that's this number here, 42 out of 90. Just read that off the tree. That's 42 out of 90. And we can divide top and bottom by 6 to reduce it. 7 out of 15. Probability of at least one has brown, well, that's one or more, so it would be these top 3 paths, at least one has brown, right? The only one that's out of B in it would be the bottom path. So it'd be 42 out of 90 plus 21 over 90 plus 21 over 90. It'd be 84 out of 90. And we could reduce that, divide top and bottom by 6. It reduces to 14 out of 15. Okay, so then the probability of exactly one has brown, so that'd be these 2 middle paths, brown and not brown, or not brown and then brown. So 21 out of 90 plus 21 out of 90. So it's 21 over 90, 21 over 90, 42 over 90, and that reduces to 7 out of 15. At most one brown, so that'd be one or less have brown. So the only one we want to exclude would be the top path, brown. So it's one has brown or fewer. One or fewer has brown. So 21 plus 21 plus 6. So it's let's fold this. So it's 21 over 90 plus 21 over 90 plus 6 over 90, 48 over 90, and that reduces to 8 over 15. Probability neither has brown eyes. That would be the bottom path. Not would be 6 out of 90, and that reduces to 1 out of 15. Okay. I think that's it. Okay, so that concludes this presentation.